Let's antidifferentiate this expression. So as we do that, what they're asking us to do is actually find the antiderivative of this whole thing. So we could express this with integral signs instead. All right, so one term at a time, let's go through and find the antiderivative. So antiderivative of e to the x is just going to be e to the x. On the middle term, it's a constant, so what we could do is go ahead and say, well, the constant comes along, but we have to put an x with it. And we can double check that by thinking, well, what's the derivative of 12x? It works out to be 12, this number in the middle. What's the derivative of e to the x? It's e to the x. Now that last term, you'll notice that we have x in the denominator. If we move that up to the numerator, we get x to the negative first power. But we're going to run into a problem that we're not allowed to use the power rule in this one circumstance, all right, because it ends up dividing by 0. So this is the special case where we can bring along the minus 16. This works out to be the natural log of the absolute value of x, and we'll include a plus c at the end for any constant could be attached at the end. Because the derivative of any constant would just be 0, there could be a plus 0 at the end of this integrand.